Types of viscosity of the fluid. This is the today's topic. So there are two types of viscosity of the fluid. Two types. Of viscosity. Number one, dynamic viscosity. And number two, kinematic viscosity. So these are two types of viscosity, and now we will see that what is the dynamic viscosity and what is the kinematic viscosity. So now let us take the dynamic viscosity. What viscosity we study in the class 11th, that is nothing but the dynamic viscosity. So the coefficient of viscosity, that is called the dynamic viscosity, and this is taken when the liquid is flowing in some tube or in some pipe or somewhere else on the ground. So this viscosity counts for the flowing of the liquid. The coefficient of viscosity of the fluid is called dynamic viscosity. Denoted by eta or the mu. Generally we denote it by eta, but sometimes this is also denoted by mu. So now, as we have the unit is kilogram per meter second. This is what the unit of this dynamic viscosity or the coefficient of viscosity. We can have the example. Dynamic viscosity of water, and that this eta or mu, this is 10 raised to the power minus 3 kilogram per meter second. Similarly, the dynamic viscosity of air, now that is eta or mu, that is equal to 10 raised to the power 1.2 into 10 raised to the power minus 5 kilogram per meter second. So these are simply the coefficient of viscosity of the air and coefficient of viscosity of the water and so many other liquids that we are having. So we have different values of this dynamic viscosity of the liquids. This depends from liquid to liquid and changes from liquid to liquid. So this is what the dynamic viscosity. Now we see the kinematic viscosity. Kinematic viscosity. Now difference between these two is that whenever we have to study theoretically the viscosity, then we take the dynamic viscosity. But when we are using this in the engineering, then there we use the kinematic viscosity. It is the ratio of dynamic viscosity to the density of fluid. And it is denoted by nu. So what we have that the kinematic viscosity equal to dynamic viscosity divided by density So this nu is equal to dynamic viscosity is nothing but the eta or the mu upon density, that is now rho. This is now we have one more relation for this kinematic viscosity. This nu equal to V into D upon Re. This is also the, so what we have here now, this where this V equal to velocity of flow of the liquid and D the diameter of tube or pipe. Re Reynolds number. So now from here you can have the unit of this nu, So this is now equal to meter square per second, or we can have the dimensions that is now m0 L2 t minus 1. The kinematic viscosity is the kinematic viscosity is used in engineering. So whenever we have to apply the liquid for the different machines, then we have to study the kinematic viscosity of the fluid. So these are the two types of viscosity, one the dynamic viscosity and second the kinematic viscosity. Both the viscosities have their importance at the individual places. When we study theoretically, then we have the dynamic viscosity. When we use it in the engineering in different machines, then we study the kinematic viscosity. So thank you very much.